So this is the other methods by which we can synthesize indole derivatives. In your last class, the Fischer indole synthesis, which is actually synthesize indole from phenyl hydrazine, and Rayzard synthesis is there. Now where we discuss about the Lane-Gruber batchosynthesis, where orthonitrotoluene derivative is used, and this specific R represents the any substituent can be present in the phenyl ring, and in the presence of 2-methyl formamide, and the reagent used for this reaction, or that is your pyrrolidine, that is whenever we reduce pyrrole we get the pyrrolidine structure. So pyrrolidine is used for this reaction. Now whenever this pyrrolidine and orthonitrotoluene reacts, we get a specific intermediate. The pyrrolidine moiety is attached with the methyl group present in the structure. Now this is not the final product. Whenever a reduction reaction is there, as you know, the ranny nickel is one of the common reducing agent used for organic reactions. So ranny nickel is used to reduce the intermediate, and finally we get the substituted indole. R represent the substitution. Now go to the next one, that is Sakai synthesis. Now Sakai synthesis is the synthesis where two as the ethine group is present in this substituent here, that is your ethine group. That is why the compound is 2-ethinyl amine derivatives, and in the presence of toluene and under the reflux condition, and the reagent used, that is 5 mole percent indium bromide. In cyclization reaction, cyclic ring formation reaction is there, and after the cyclization we get the final substituted indole derivative. Now this method is ideal for the synthesis of substituted derivatives of indole. Now the substituents present for this reaction is designated as R1, R2 and R3. Now remember, R1 substituent is it is present in the starting material also in the phenyl ring, but the R2 substituent or R3 substituent are come from the side chain of the reaction. Now the third reaction by which we can synthesize indole, that is from 2-amino benzaldehyde, and this 2-amino benzaldehyde, you can see that two position of the benzaldehyde is substituted with the amino group, and that is why the compound is named as 2-amino benzaldehyde, and the reagent used for this reaction is TMSCHN2 here represented. Now the complete name of this reagent is trimethylsilyl diazo compound, trimethylsilyl from silica, diazo because two nitrogens are present in the presence of methanol CH3OH at 60 degrees Celsius temperature. At 60 degrees Celsius temperature the reaction is carried on, and finally we get the indole moiety. Now if we go to the green chemistry approach, here the microwave assisted synthesis of indole is there, where a aniline derivative is taken at first, and under the microwave condition we get the indole, obviously with a aromatic substitution. Of indoles are discussed. Now indole undergoes the electrophilic substitution reaction mainly at 3 position. It is mentioned over here and highlighted 3 position, and whenever 3 position of the indole nucleus is occupied, whenever the 3 position is occupied by the other substituents, whenever 3 position is occupied by the other substituents, the hydro other than the hydrogen, so the reactions or the position for electrophilic substitution is position 2. So generally 3 position is for electrophilic substitution, but if 3 position is occupied, then the position 2 is for electrophilic substitution reaction. Now when 2 positions and 3 positions both are occupied, then the electrophile occupies the position in the benzene ring present in the system, because indole is a fused ring system. Two rings are present in the structure. One is your phenyl ring, another one is pyrrole ring. Now, the generally electrophilic substitution reactions takes place at 3 position rather than 2 position. There is a specific reason for that, because the attack of electrophile at position 3 generates a carbocation. Remember, generates a carbocation which do not disturb the aromaticity of the benzene ring. That is why the electrophilic substitutions mostly occurs at 3 position. But remember, whenever the 2 position is there, or if the substituents taking 2 position for electrophilic substitution, then they also generate a carbocation, but that specific carbocation disturb the aromaticity or the aromatic character of the compound that is there. Because of this reason, the substituents or electrophilic substitution mostly preferred at position 3. Now, as well as the electrophilic substitution is there are some nucleophilic substitution is also there for uh, indole structure. Now, this is a list of substitution reaction is there. Now, see, electrophil among the different electrophilic substitution, we will focus on 4 reactions here. So, at first, we will discuss about the nitration of the indole. Next, you know that halogenation, that is most common reaction. Third one is the sulfonation of the reaction, and fourth one is a Manich reaction. You know, specific naming reaction is there, that is Manich reaction. Among the nucleophilic substitution, we will discuss today only about the reaction with the butyl lithium. Now, this is the reaction. At first, nitration. Now, you see, this is your indole, and the reagent used for nitration is acetyl nitrate as well as the pyrrole. And the position for electrophilic substitution, just I previously told that 3 position is there for electrophilic substitution. So nitro group will be attached at position 3, and the compound is 3 nitro indole. Now this is all about your nitration. Then go for the next one, that is halogenation reaction. Halogenation means any of the halogen may react for this reaction. Now this is your structure of indole. Now the reagents used for this reaction is bromine. In the presence of acetic acid, whenever indole is react, they actually produce 3 bromoindole, that is bromine substitution at position 3. Now the next reaction, that is sulfonation. Again take indole. Now, as whenever we discuss about the sulfonation of the pyrrole, you can see that pyridine sulfonate is used as a reagent for the sulfonation for pyrrole, as pyrrole ring is present in the structure of indole also. That is why the indole 3 sulfonic acid is the indole 3 sulfonic acid is the reagent uh, product for the sulfonation of the indole 3 position is substituted with the SO3H group. Now the fourth reaction among the electrophilic substitution for this section, that is Manich reaction. Whenever indole react with the dimethylamine, this is the structure dimethylamine, in obviously in the presence of a specific reagent, that is formaldehyde, it is converted into gramine, and this is a specific substituent present at position 3, that is CH2NCH3 whole 2. Dimethylamine group is there with a specific methylene bridge. Now this is the last reaction for this section, that is nucleophilic substitution reaction. Here indole is react with N-butyl lithium along with ether, and this specific reagent is react with whenever butyl lithium react with the indole, two position of the pyrrole is actually substituted with the lithium moiety, and here the indole is not the simple one, it is a methyl substituted derivative of indole. Now the methyl group is not disturbed after the reaction with butyl lithium, and whenever this lithium substituted compound react finally with CO2 and the H plus ion in acidic condition, they actually produces the carboxylic substituent, and that means two position of the indole ring is substituted with the COOH group. Okay, thank you.